Hello students. Today we'll explore the fascinating world of permutations and combinations. In mathematics, permutations and combinations help us count how many ways we can arrange or select things. These are part of a larger field called combinatorics. Permutation deals with arrangement. Order matters. Combination deals with selection. Order does not matter. Factorial. N factorial. Factorial is the backbone of both permutations and combinations. It is the product of all natural numbers up to a given number. N factorial equals n minus 1, n minus 2, 2 into 1. Note, 0 factorial equals 1 by definition. Suppose you have 3 different books and want to arrange them in a row. You can choose the first book in 3 ways, the second book in 2 ways, the third book in 1 way. So total arrangements equals 3 into 2 into 1 equals 6 equals 3 factorial. Permutations. Permutations refer to arranging items. Order is important. The formula is as follows. PNR equals n factorial divided by factorial of n minus r. Let's understand this with an example. How many ways can you arrange 3 out of 5 books on a shelf? First spot, 5 choices. Second, 4 choices. Third, 3 choices. Total equals 5 times 4 times 3 equals 60. This is P. 5. 3 equals 5 factorial. Divided by 5 minus 3. 60 equals 120. Divided by 2 equals 60. Permutations with repetition. Identical items. If some items are identical, we divide to eliminate duplicates. The formula is as follows. Permutations equals n factorial divided by P1 factorial into P2 factorial into ... Let's understand this with an example. The word level has 5 letters, L appears 2 times, and E appears 2 times. Permutations equals 5 factorial divided by 2 factorial into 2 factorial equals 120 divided by 4 equals 30. This is because switching the 2 L's or E's doesn't create a new arrangement. Permutations with repetition allowed different items. Sometimes we are allowed to repeat items in arrangements. The formula is as follows. N raised to the power r. Let's understand this with an example. Example 1. Create a 3-digit code using the digits 0 to 9 with repetition allowed. Total codes equals 10 raised to the power 3 equals 1000. Example 2. Form 2-letter words using A, B, C, where repetition is allowed. Total equals 3 raised to the power 2 equals 9. AA, AB, AC, BA, BB, BC, CA, CB, CC. Sir, may I ask something? Of course, please ask. How is circular permutation different from regular permutation? In circular arrangements, like a round table, we fix one position to avoid equivalent rotations. The formula is as follows. n minus 1 factorial. Let's understand this with an example. 5 people around a round table. Fix one person. Arrange the rest for 4 factorial equals 24 ways. Combinations. Combinations deal with choosing items. Order doesn't matter. The formula is as follows. CNR equals n factorial divided by r factorial. Factorial of n minus r. Let's understand this with an example. Choose 3 students from 7. C7 3 equals 7 factorial divided by 3 factorial into 4 factorial equals 40 divided by 6 into 24, which equals 35. Relationship between permutations and combinations. PNR equals CNR times r factorial. Interpretation. First choose r items, CNR, then arrange them, r factorial. Envelopes problem. Derangement. How many ways can you place 3 different letters in 3 different envelopes such that no letter goes into its correct envelope? The formula is as follows. Dn equals n factorial into 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus ... plus minus 1 raised to the power n upon n factorial. For n equals 3, d3 equals 3 factorial into 1 minus 1 plus 0.5 minus 0.1667 equals 6 into 0.3333 equals 2. Answer 2 ways. Let's understand this with an example. A committee of 4 people is to be formed from 6 men and 4 women. Total equals 10 people. C. 10 4 equals 10 factorial divided by 4 factorial into 6 factorial equals 210. Example 2. How many 3-digit numbers can be formed using digits 1 to 5 with no repetition? First digit 5 choices, second 4 choices, third 3 choices. Total equals 5 times 4 times 3 equals 60. Example 3. How many 2-letter words not meaningful can be formed from ABC? With repetition, 3 times 3 equals 9. Without repetition, 3 times 2 equals 6.
Example 4. How many ways can 4 people be seated in a row? Answer: 4 factorial equals 24. Example 5. In how many ways can 5 different letters be posted in 5 different post boxes such that exactly 2 letters go into correct boxes? Answer: C. 5. 2 times D into 3 equals 10 times 2 equals 20. Example 6. How many 4-digit numbers can be formed using digits 1 to 9 such that digits do not repeat? Answer: 9 times 8 times 7 times 6 equals 24. Example 7. How many combinations of 3 letters can be made out of letters A to F? Answer: C. 6, 3 equals 20. Example 8. From 8 students, how many ways can we choose a president, a vice president, and a secretary? Answer: P8 3 equals 8 times 7 times 6 equals 336.
That's all for today's session. If you have any doubts, we'll take them up in the next class. Jai Hind.